Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside, and in the last video that I just did, we solved radical equations, square root equations specifically here. Now we're going to solve any sort of equations with rational exponents here. That could include to the 1/2 power, and I don't know if I actually have any to the 1/2 power, but I'll kind of use an example of that to make sense of what we just did previously and what we're doing here now. Not necessarily more difficult in any way. It looks a little more confusing, but I promise you, if you know what you're doing regarding radical, rational, whatever things, it can help. And I need to do probably some transformations with you. There we go. Let's jump right into it here. And before starting these problems here, I do want to kind of get that jump start and talk about what did we last do and how does this apply to that. So let me kind of go up and for starters here, let's note that when we raise something to a rational exponent right there, there is a conversion of sorts. It is the nth root of x to the m power, and I'd be remiss to avoid also saying that you can also take the nth root of x first and raise it to the mth power thereafter, which is just kind of the way that I tend to actually do it more so. These are both the same thing. It just states in what order that we do them. Either is really acceptable regarding what we're doing. But the point is, raising it to this exponent there is equivalent to that. How often will I actually represent it that way? I might have to for you guys, all depending on what we're doing. Maybe after one or two, maybe you'll know exactly what we're doing each time. But I don't want to represent it that way to start with. I don't want to turn it into two steps when it could just be one. If you need both steps, okay, I suppose we can look at that. Anyway, what we last did here, and I'll make a let's do this. What we last did here is a square root of x minus 3 plus 4 equals I don't make it too big, equals 9. So right here, when we tried to solve something like this right here, we would have to isolate that radical and then square both sides. Now, what if this problem instead didn't look like this? Let's change the color scheme. Instead of looking like this, let's say instead it looked like this right here, x minus 3 to the 1/2 power plus 4 equals 9. Because if you know what we're talking about right here, this is x minus 3 to the first power, and it is the second root of that. So this is that conversion into this. These are the same thing. Now, when we did these problems at the time, what we would do is we would subtract 4 over, so it'd say square root of x minus 3 equals 5, and then we would square both sides like that, squared and squared. Now, that's going to be the same thing that we're going to be able to do in this problem down here, where once we subtract 4 from both sides, it says x minus 3 to the 1/2 equals 9. And then we would square both sides here as well. So, raise it to the second power. And, kind of notice what it does here. Why does it cancel out the square root? Well, for reasons of that's what square roots and squares do, but also, what happens to these two right here? Another property that's going to be involved is this one. When you raise x to the m and then to the n power, it results into the x to the m times n power. I get to multiply 1/2 with 2, and 1/2 times 2 is 1. So what happens there is that, that goes away right there. It cancels out in that kind of way. Now, what you're going to see in these particular problems right here is generally there probably won't be a 1 over something. There could be. But there generally won't be a 1 over something. Otherwise, if it was, we would see it as a cube root or something like that. So you'll generally see them instead with something else. And so when we raise it to a power, we want to raise it to the power that would give us 1. So, one last property to get, this is an exponential property, just an overall idea. A over b times b over a equals 1. You multiply something by its reciprocal right there, and you get 1 out of it. And that's what we're going to try and do here. So in these problems, and I don't know, I feel short on room, but in these problems right here, like this first one, x to the 3/2 power equals 343. If I raise this to the 2/3 power right here, to the 2/3 power, boom, and this to the 2/3 power, then, 3/2 times 2/3 is 1. That'll cancel out what goes on there, and you are just left with x. And then right here, to the 2/3 power, if you don't, we're not going to take 2/3 of 343. We are going to be taking the cube root of 343 and then squaring it. I don't know if I mentioned or not, but I'm not planning on using a calculator for this thing here. So the cube root of 343 is 7, and then that'll be 7 squared, which is 49. 9, like that. So we would just have that, and then we'd be done with the problem. And, you know, will I always be converting this? No, but the first couple of times I think I want to actually do that. Now, alternatively with this problem here, what if you converted from the beginning into, this would be the second root of x cubed, and of course if it's second root that means square root, so I don't really need that here. So maybe you can convert it like this if you really have trouble and make it a two-step thing and say, I want to square it. Well, I don't want to square things first, actually. I'd rather cube root things first. But, you know, boom. So you'd say, I want to take the cube root. Oh, this would look weird. I want to take the cube root of both of these here. And now I just have the square root of x equals 7, and then I square both sides, and then I get, once again, x equals 49. So that's kind of a weird approach to writing that. That looks a little weird for me, so I'm going to probably just stick with those. But you're starting to get the gist of what's going on here. And anyway, I didn't want to overspeak on it. I might have perhaps, but I want to give that luxury to anyone who wants to do it in a different way, how it can be done. Okay, number 2 here. 1 over 729 equals x to the negative 3/2 power. Now, we could do this all in one step. I don't want to confuse you with it too much, though. But if you do notice, I'll read it so it's on this side here. If you do notice, we do have a negative exponent there. Maybe let's do this one in 2 steps, at least the first time, so you're not overly confused on what's going on. You know, if I raise this just to the negative first power to begin with, just the negative first power, then that eliminates that, you know, I'm going to turn this positive. That eliminates the whole need for the negative exponent. This can become x to the 3/2. But what's the benefit of this right here is raising this to the negative first power turns into 729. So it takes away that fraction portion of it. And if that helps you, I'll probably do that for these problems. I don't know if I need to write to the negative first power, but that's what I just did. I turned the exponent positive, and in doing so, I reciprocated the other side of this. So now we get to raise this one to the 2/3 power, and you just saw this in the last problem here, to the 2/3 power like that, and then that leaves us with x. And then on the other end of this, once again, that is the cube root of 729, and then we got to square that thing. Now, the cube root of 729 is 9. I got to check really fast. I made a power table for my students. I want to see if that's on there. It is. Okay, cube root of 729 is 9. And then we have 9 squared, which is 81. And then voila, we are done. So those are the first 2 problems there. And, you know, I should mention right now, if you saw my last video, we had to, when we solved our equations, we had to check for extraneous solutions. These problems won't have extraneous solutions. And, you know, it's possible they could, where, and I'm going to float through the problems right now. It's possible they could, let's say you had just this on this side right here, a negative, and then you ended up squaring it. Yeah, you'd probably have an extraneous solution. But if we isolate this thing, which is what we're going to do, if we isolate this guy right here, this guy right here, we won't end up having a negative anymore. The reason the square root problems had extraneous solutions were twofold, or 2 different reasons. Number 1, if you did have a negative on the other side when you did square both sides after the radical is isolated, that would cause an extraneous solution. But number 2 was if you had an x variable outside of your radical, outside of what we're going to be raising to a rational exponent. In these problems, you are going to see a single x. Or number 3, if you had it in a different radical, or whatever, in this case a different rational. Here you're going to see a single x. So unless it's being raised to a power and then it equals something where you have a negative on the other side, you don't need to anticipate extraneous solutions at all anyway. You're good. But you can see the problems are going to get a little, This video is going to be a little longer than our previous one here, as this one's already reached the 9-minute mark. That's already more than half of what the other video was. We've only done 2 problems. All right, let's move on here. Number 3. Now, I did mention we do want to isolate this thing right here, just like radicals. So it's kind of the same kind of problem like that. A little less so. You're solving it differently. You're not squaring a binomial and things like that. If I subtract 7 over, I'm going to get 27. So, you know, right here we get to now raise it to the 4/3 power, to the 4/3 power, like so, right? So here, if you recall, the thirds power portion is the 4/3 is taking the cube root of, and then raising it to the 4th power after that. So let's just do that in 2 steps there. Cube root of that is 3, and 3 to the 4th is 81, like that. So again, no extraneous solutions to speak of in a problem like that. You're set. Number 4, here, let's add 7 over, and we have x to the 5/4 equals 243. And now we get to raise that to the 4/5 power, and this to the 4/5 power. Again, my students will have what's called a power table. Basically, they're trying to find out something to the 4th power is 243, or to the 5th power is 243. What is that value? Because I got to take the 5th root of that. That's 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So that will be, once again, 3, and now we are doing that once again to the 4th power, and that will, once again, be 81. So we got 81 from 2 different kinds of problems, 2 different setups, but it was still 81 in the end. It's kind of hard to sometimes get different answers out of these, as you can see. All right, number 5. This one is already isolated, but raised to the -1/2 power. So as I said before, if I want to raise it to the +1/2 power instead, that can reciprocate the other side and turn that just into 5. And listen, this problem, oh, that's a p. I wanted this to have an x. You know what? Is it okay if I make it an x? I wanted them to all have x's. That's just a personal thing. Okay, and listen, this problem is a lot like all the radical ones you had before. Hey, I could have turned it into this. Square root of x minus 24 equals 5. Look familiar? You can square both sides. And remember, like I said, times 2 over 1, okay, or square it, right? Same result, to the 2 over 1 power or squared. Same thing. What do we get? We get x minus 24 equals 25. Add 24 to both sides. X equals 49. And once again, no extraneous solutions here. There's only one x that exists in this entire thing inside the radical. The other side of it is a positive number or 0. You're not going to get extraneous from that. Okay, number 6. We want to isolate this thing as well. And I say isolate as in there's still a 2 multiplying in front of it. Please divide by 2 to begin with right here. Do divided by 2, do divided by 2. Several reasons that I'm just not going to get into regarding properties and what if it was a negative in front of it? You know, you'd want to take care of that as well. So x to the 2/3 power equals 9. Okay, we're going to raise this to the 3/2 power. Now, this problem is going to be slightly different than the other ones, though, and here's the reason. Okay, I want to get into it. Sorry, I want to get into it this way instead. Now, I'll go back to this. I'll go back to this one here, but I just want to get into it this way instead. What if we talked about it in the other way where we have the cube root? It's the cube root of x squared, right? We've gotten into that idea here. I have to take the square root of both sides, things like that, and that equals 9. So let's do this in 2 steps, or show what the first step is in this way. What if I started by taking the square root of both sides like this? Well, what you have to remember, see, when we've done other problems like this, what if it just said x squared equals 9 and take the square root of both sides? Well, that would be x is plus or minus 3. Plus or minus 3, because it is a square root. It is an even root of something, because if I squared both sides, squaring a -3 would give you positive 9, squaring a positive 3 would give you positive 9, either or here. So the square root of this one is the same thing. Doesn't matter if there's an x cubed or cube root of x, that is still... you can take a cube root of a negative number and all's good. There's nothing that changes right there. But taking the square root of both sides, this would turn us into the cube root of x equals plus or minus 3. There is more, plus or minus 3. There's more than one answer to this thing that can get you that value. So that is going to exist here. And then when I cube both sides there afterward, then that's going to be x equals plus or minus 27, because cubing positive 3 and cubing negative 3 get you different answers there. Positive 27, negative 27. And that's what happens here as well for this problem, where if I do that to the 3/2 power, I can start by saying x equals, and plus, well, I'll do the whole thing. X equals plus or minus 3 cubed, and x equals plus or minus 27 right there. So I'll slow down there for a second just to let you process what you just saw here. Let's start with, Mr. Robinson, why didn't you do that in previous problems? Let's look at the previous problems and what we did. Let's look at numbers 1, 2, 3, and 4, and look at what we raised x to each time. To the 2/3 power, 2/3 power, 4/3 power, 4/5 power, 2 over 1 power. What they all have in common is the denominator of these... Let me get a different color. The denominator of these rational exponents that we raised to were all odd numbers. And raising it to an odd number denominator thing means you're taking an odd root. The cube root, the fifth root, or in that one case, the first root, which doesn't change the number. Taking a cube root of a negative value leaves you with a negative value. Taking the cube root of a positive value leaves you with a positive value, or any odd root. Taking the square root of some positive value, well, it's still positive, but when you take the square root of both sides, when it has to do with a variable, you have to remember that going the inverse version, if you squared a negative or positive, it turns positive. So you don't know whether it was negative or positive. Not something I have to get into because you've seen it before, but that's when you raise it to an even versus an odd root. So you have to be consciously aware of what's actually happening with it. It's not just square root. It's also fourth root, sixth root, eighth root, any of those as well. So you got to be very, very careful of that. What else happened there? Well, it was the plus or minus portion of it. I think that was just the big thing to process. So I wanted to break it down for you right there. You take the square root of both sides. There's that plus or minus effect going on there. It doesn't happen with a cube root or a fifth root. All right, let's jump into number 7. So just be very mindful of that. I will be, and I hope that you can as well. So number 7, let's isolate this guy right here by doing 2 steps. I'm going to subtract this 4 from both sides like that right there. So I now have negative 4 x to the 3 halves equals negative 500. And then I got to divide both sides by negative 4. And that is an important step for this thing when it comes to isolating that stuff. So that's x to the 3 halves equals 125, positive 125, like that. Okay. So, nothing new regarding what you saw in previous problems there. We get to raise both sides to the 2/3 power. That's an odd number, to the 2/3 power. Okay, and that leaves us with x equals cube root. Let's see if we can do this in one step. Cube root of 125 is 5, and then 5 squared is 25. X equals 25 right there. It's calculator free. I did take the cube root first, and then I squared it. All right, number 8. See, that's the stuff that can speed it along in those ways. Number 8. This quantity is raised to the 2/3 power, so we just got to divide by the negative 4 on the outside. That's our kind of beginning step here. So x minus 14 to the 2/3 power equals, positive 9. And if I raise both sides to the 3 halves power, and if you notice there, 3 halves power does indeed mean you are taking the square root. So taking the square root of both sides would leave you with x minus 14 equals, and this is plus or minus, once again, this is plus or minus 3 cubed, right? So square root of 9 is 3, and 3 cubed is 27. Remember, square root of 9 isn't positive or negative 3. The square root of the other side actually leaves with an absolute value. I'm not going to get into that. But anyway, the plus or minus exists as a result of taking the square root of something with x in it. So plus or minus 27. So there are 2 different answers that are going to be here. I got to add 14 to both sides. 14 plus or minus 27. We're not done. We have to actually write those. See, last time it was positive 27 or negative 27. Well, 14 plus 27 is a different number than 14 minus 27. Let's figure out what those are. X equals 14 plus 27, which equals 41. Or x equals 14 minus 27, which is, I think, negative 13. I'm kind of slow right now. Or negative 13 right there. I know some people's OCD are kicking in, but I'm going to change the screen anyway in a moment. I just hope I have the right answers there. Like the right addition. Should be good. All right, and those are those 2. I still have 6 more problems to do as they get a little more rambunctious. And, you know, honestly, there's not much more that's happening with the problems. There's just more that you have to do before you get it by itself, sometimes. This one right here, it's already by itself-ish. You can see one thing I want to do with the negative exponent. First of all, I'm going to write this on the right side of the equation, but I'm going to raise them to the negative first power. I'll make this a positive exponent first. I think it's really in everyone's good nature to just start with that. And then we can go ahead and raise these to the 3/4 power. 3/4 power here. 3/4, 3/4. Once again, be mindful. That is an even root right there. You are going to be left with a plus or minus when we do this here. So 9x minus 1 equals plus or minus. So this 4th root of 625 is 5. So we got 5 cubed there. That's 125, excuse me, plus or minus 125. So 2 different answers here. So 9x equals 1 plus or minus 125, and x equals 1 plus or minus 125 over 9. Once again, let's get those two different answers out from that. It's either 126 over 9 or negative 124 over 9. Can these divide by 9? 126 can divide by 9. That is, I just know 1 plus 2, anyway. 90, 36, 14? 14, I think. So 14 for that guy. This can't divide by 9. And can it reduce? Can 124 divide by 3? I don't think so. No. So I don't think I can reduce. I think that's it. So we kind of have a fraction answer on that one. But it's two different answers. It's two different answers. The fourth root's an even root. And we go off of that. Okay, number 10. I'm going to subtract 9 over. Negative 27. And I want to divide both sides by negative 1 right there. There's a difference between a negative exponent and a negative base thing right there, right? Or it's not even a negative base. It's just the negative 1 in front. So that's 35 minus 2x to the 3/2 equals 27. Okay, let's raise those both to the 2/3 power. 2/3, 2/3. I think we've seen 27 to 2/3 a couple times, or maybe the other way around. That's going to be 35 minus 2x equals, cube root of 27 is 9. 3 squared is 9. Right there. So basic algebra here on out. I know it can look more complicated inside, but there's nothing else really that changes there. I just got to figure out 9 minus 35. I think it's negative 26. And divide by negative 2. X is 13. One answer. All right, let's keep moving on. I don't think these problems get any more tricky. They're just more steps to do and just making sure that you can follow your own process along the way. I'd like to add 1, please. I'd like to buy a vowel. I don't know if the problems, the things that we raise have to take a root of get any larger or anything like that. Negative 243. We've got to divide by negative 3 now. So 2x plus 7 to the 4/3 equals 81. Sorry, I don't know why I thought about that for a second. 81. Raise them to the 3/4 power. Okay, this is an even root right there, so we will be left with a plus or minus. So plus or minus. 4th root of 81 is 3. And 3 cubed is 27. So plus or minus 27 right there. So 2x equals negative 7 plus or minus 27. And x equals negative 7 plus or minus 27 all over 2. Okay, here we go. So negative 7 plus 27 is 20. And 20 over 2 is 10. Or negative 7 minus 27 is negative 34. And negative 34 over 2 is negative 17. I should really check my answer key just to make sure that every little number I did was accurate with those. For some reason, my subtraction and addition feel a lot less, I feel a lot less confident with those right now than like multiplication and division. I'm not sure why. Is this just squared? There must be something else. Okay, there it is. All right, add 4, divide by 3 right here on number 12. 81. 81 divided by 3 is 27. See, a lot of the numbers, we're getting a lot of the same numbers out when we're doing these, like the cube root and the 27, things like that. It happens. You're just doing a little step here and there that's going to change some things. So to the 2/3 power here. And the cube root of 27 is 3. 3 squared is 9. So we're going to get x minus 17 equals 9. Add 17, we'll get 26. See, I wrote 27. I said 26. We get 26 right there. 2 more problems. I am almost done. I am so excited. Okay. Divide by negative 2. I don't know why I gave myself so much space. 243, positive 243. And we get to raise both of these guys here to the 4/5, which means we got to take the 5th root of 243, which was 3. And then 3 to the 4th is 81. So this will be 4x minus 11 equals 81. Add 11, divide by 4. 23? 23, I think. 23, yeah. Add 11, Divide by 4. Okay. Again, I'm a little less confident on this. Okay, last problem right here. We are going to add 1. So 162 equals 2 times 55 minus x to the 4 thirds. We're going to divide both sides by 2. There's our 81 again. That's a 4 thirds, by the way. And we get to raise both sides to the 3/4 power. 3/4 for being an even number there. It means the 4th root of, which means plus or minus will be involved. Right there. So this will be, let's put this on this side, 55 minus x. And here we have plus or minus. 4th root of 81 is 3. 3 cubed is 27. That's not original. It's not something we haven't seen before. Oh, and we lost it. And I'm going to subtract 55. Well, yeah, I'm going to subtract 55. Now, this will look kind of weird to you guys right here. I'm going to divide everything by -1. I'm going to change all the signs. So x equals positive 55. X equals 55 plus or minus 27. Now, you might go like, wait, I thought you multiplied these by -1. Won't that become minus or plus 27? I mean, what's the difference? It's still plus or minus, right? Just this, now this is a positive 55 instead of negative 55. That's really the only part that changes the answer there. If you'd like, you could evaluate this first and then change your signs, but I'm going to change it right now. So 55 plus 27, 82. Yep, 82. Or x equals 28. Really? I think so. I'm just going to double check my own little work right here. I might have an answer key somewhere on another screen. Give me 1 second. 82, 28, 23, 27, 26, negative 124, 9. Okay, I'm trusting that they're all good. 41 and 13, we got, or negative 13, so we got on that one there. Okay, it's looking all good there. All right, guys, ladies and gentlemen, that ought to do it for this one right here. This is Mr. Robinson. Thank you so much for watching. I hope it made sense, even without a calculator there. I hope I got them all correct. If you have any other questions, let me know in the comment section down below. Take care. I will see you in the next one.